We spent 2 days on the skills that were needed for like long division, although we don't probably use, like most people, you know, when I said you all have a favorite, everybody's favorite is synthetic division, right? You like that better than long division. It's a lot less writing. It's way faster. So there's that. We won't use long division much in what we're doing now, but it's still a skill that comes up that's needed once in a while, and it's still important to see it before we use synthetic, because synthetic is just a tricky way of writing out the long division process, right? Okay, so we spent 2 days on those skills, and then not yesterday, but Thursday, we did remainder theorem. I'm just going to show you, remind you what it is. So this was our remainder theorem lesson. Remainder theorem says that if you take a function like f at x, so our first example was that one right there, and divide it by x minus a, then the remainder is f at a, right? And that's what we learned on Thursday. That's very important for what we're doing today. And but that was simple. Like there's the linear systems question, but other than that, it's pretty easy stuff. It's just BEDMAS questions, basically, right? But here's the trick, is there's a very special case, and it's very important. And if it says, so you should write this down, but we're going to talk about factors a little bit, and then we're going to see what it's like to actually use it. If f at a is 0, so 0 would be the remainder when you're dividing by x minus a. That's like saying the remainder theorem, although it's kind of backwards from how we presented it before. But then we know that if I divided by x minus a, I would have no remainder. The remainder would be 0. Why is that important? Well, it tells us that that thing, x minus a, is a factor of f at x. But before we go on, well, what is a factor of something? So I'm going to talk about a numerical example here. Okay, so 24. And these are going to be factors up here, and these are going to be not factors down here. What are the factors? Somebody name a factor of 24. 3. Thank you. I like that one. 6. Go ahead, shut them out. 8. I heard 2. I heard 8. I heard 12. 24 and 1, kind of. They're not really useful factors, but sort of, right? Is that all of them? 4. No, 4, thank you. Yeah, it's like, I think somebody's missing from that list. And they pair up. 12 times 2, 6 times 4, 8 times 3. I think that's all of them. Somebody name something that's not a factor of 24. 17, 7. So we got 1, sort of, 2, 3, 4, 5, 6 is, 7's not, 8 is, 9's not, a million, not a factor of 12, right? What makes those things factors, whereas those things are not factors? That's a very common language that we use there, isn't it? It divides evenly into. And what does that mean? That means if I divide, I get a whole number, not a decimal. Or somebody said this morning, kind of like what this says, you would get a remainder of 0. When you divide by those things, if you were doing that long division process with numbers, you would get a remainder of 0. Divides evenly into. That's what that means. And there's this thing that you did in elementary school, and you may have done it a little bit in grade 9, and it would look something like this. I can take 24 and break it up into, what do we start with first here? 3 times 8. And what can I break 8 up into? 4 times 2. So this is 3 times 4 times 2. And what can I break 4 up into? 3 times 2 times 2. And then the other one that we had times 2. And this is a unique list. This is called prime factorization. And if you took any kind of number theory course in university, you might explore some stuff. It seems pretty simple, but there's actually, a little bit more to it, and you can kind of explore some things around this. But anyway, that's not what we're doing. But prime factorization, so I've broken it, that number 24 down into its list of prime number factors that multiply back to 24. That's a unique list, right? So every number has its own unique list of primes that multiply to it. And that's sort of something that could be explored, right? But it's not what we're doing. But if you think about factoring, when we're doing factoring with polynomials, we're doing the same thing. We're breaking up, if you're just factoring a quadratic, you take a trinomial, let's say, and you break it up into two binomials. And those two binomials cannot be factored further. Maybe there's a common factor involved, something like that. But you understand what I'm saying? So you've got, they're not prime numbers because they're binomials or polynomials, but you factored it as much as you can until you get things that are no longer factorable. And it's one thing times another, right? A binomial times a binomial, which gives you the trinomial. So people following what I'm saying here? So polynomial factoring is the same process. In the past, you were factoring degree 2, maybe a degree 3 if it had like a common factor of an x in it, right? You might have seen something like that in grade 10 or grade 11. But really, all the factoring we do is quadratics. And now we're adding on to that where with this process, you could factor any degree polynomial. I could give you a degree 20 polynomial and you could factor it. It would take a long time because every time you would have to factor like 20 times, like you'd have to do it 20 times kind of thing. But you could. We only really go up to degree 4, maybe degree 5 here or there, but just because it takes a long time. But you could. So in grade 10, you learn how to factor quadratics, and now we're going to learn how to factor kind of everything else, any other kind of polynomial. Does that make sense? And it requires factor theorem, which is this special case of remainder theorem. So let's see what this looks like. The trick to it is, it's kind of a step-by-step process, and our first step is we have to find our first factor. Because in the past, I told you what to divide by. Do this divided by this, like the learning goal that we just took up. That's what it looked like. Do the problem of this divided by this. This is just giving us a single polynomial and saying factor it. We don't know what to divide by. But if I can find some value that when I plug it in, I get a remainder of 0, then I will know what I can, what to divide by. The trouble is the process is guess and check. There's not really an indication of what would work. Okay? So there are some tips and tricks, and we'll get to them as we go, but really, we're just going to start trying numbers until we find one that works. Does that make sense? What number do you think we should start with? Why 2? Why did you say 2? No, it doesn't have to be divisible into all the terms, although there are things about that that could be useful. So I like the way you're thinking, but we're not going to go there yet. Adam, what do you think?
Well, I was going to say, I feel like 1 would be too small because like the final number is 120. So
Why would you start with 1 otherwise?
maybe if like the last number was pretty small.
Yeah, but 1's a good place to start because that's where we start counting. It's small, it makes the math easy. But as some of you might have noticed, 1's not going to work. But we're going to write it down anyway because this is the process. I would start with 1. And you may not have to actually do the math. You might be able to tell by looking that it's not going to work, but you still kind of start with 1. And then what would I try after 1? How about -1? Because it's a little bit easier. So I would try 1, then -1, and then I would try 2. Then what do you think you would try? Then maybe I might try 3, then -3, then 4, then -4, then 5, then -5, then 6, then -6. And if you haven't found it yet, something's wrong because we're not going to make you do that much guessing and checking. Okay, there are some things that we can look out for that can help us narrow down the list. But really, it's about just plugging numbers in and seeing if they work. So we're going to try f of 1. And normally I wouldn't write all this out, but just because this is our first time through, we're going to do that. +1 is really easy because all I'm doing is adding up the coefficients, right? X to the 4, if x is 1, is just 1. So it's going to be 2 times 1 plus 5 times 1 minus 29 times 1, right? They're all going to be 1. Everybody following me okay here? I don't want to lose anybody already. So this one's going to be 2 plus 5 minus 29 minus 38 plus 120. 120 is so big, it's going to take over all those things. Does anybody know what that is? I don't have my notes in front of me. I think I left them somewhere. Somebody do that quickly so we can figure out what it is. It's 60? And in other words, not 0. So we're not done yet. Okay, let's try -1. F at -1 is going to be, so -1 to the 4th is +1, so that's 2. But -1 to the 3rd, look folks, is -1, so this is -5. So you got to do a little bit of thinking here to figure out what these numbers are. This is going to be -29, this is going to be +38, and this is going to be +120. Once again, I don't think it's anywhere close to 0. 126 sounds right to me. Not 0, so no good. Okay, what about F at 2? So 2 to the 4 is 16 times 2 is 32. If I can do some of the math in my head, it'll speed things up. But really, you're doing it on your calculator, right? You're punching this in on your calculator. And like I said, you don't have to write down every line like this. You can if you want. 2 to the 3 is 8 times 5 is 40. Okay, now we're getting some bigger numbers. 2 squared is 4. 4 times 29, help me out here. 116? Oh, minus 116. Minus 38 times 2, so is that 76 plus 120 equals, Max? Nice. 0. So what does that mean? Factor theorem tells us F at 2 equals 0. Whoops. Therefore, what? This is the whole point of doing this. Very nice. And we say it like this. X minus 2 is a factor. Or in other words, we're going to divide by x minus 2. Okay? Yes?
Why isn't it 2 minus a? Are we subbing, isn't 2x?
Because the theorem is x minus a and f at a.
Oh, f at a, okay.
Okay, so then we go off to the side and we do the dividing. So I've got 2, I've got 5, I've got -29, I've got -38. These are just the coefficients, and I've got positive 120. -38 minus 22. Watch what's about to happen here. So that's going to be -60, right? -60 times -2 is positive 120. That is not a coincidence. Why? Because we set it up for the remainder to be 0. That's what makes it a factor. Remember what we said about numbers. If you divide evenly, you're dividing into it, and you're getting a remainder of 0. If you have a remainder of anything else, what would that tell you? You've done something wrong. You've either made a mistake here or you've made a mistake here. So go back and check your work. It has to work out to 0. If you get a remainder and you keep trying to go on, like something's wrong. You can't factor with a remainder. Yes?
So is it possible for there to be larger than the number that is?
It's not just possible, it's necessary. 100%. Huh? Yeah. And that'll make sense once we're done. It'll make more sense as to why. It'll be obvious. Yeah.
Go back over that this side.
This?
Yeah.
Okay, so remember, then we say, therefore, f at x equals x minus 2 times 2x cubed plus 9x squared minus 11x minus 60 plus 0.
This also means that the quotient is also a factor?
Yeah, for sure. Okay, then we go let g at x equal 2x cubed plus 9x squared minus 11x minus 60. Because what am I doing now? I'm looking for, which is that thing, right? Because we're not done. We have to factor fully. So we got to keep going. Like, what were our instructions? Factor. Factor each of the following fully. We only pulled one part out of it. What about what's left? Right? We got to keep going. And so we start the whole process all over again, looking for another factor. Should I try 1 again? Some people say yes, some people say no. Why not? Okay, if 1 didn't work in F, is it going to work in G? No. Like, think about it. If I find a number that is not a factor of 24, so it doesn't divide into 24, will it divide into the factors of 24? No. Right? If it doesn't go into 24, it's not going to go into 12. Doesn't that make sense? So you do not need to retry the numbers that you've already tried. But 2 may work again. It could be a factor twice, just like it was for 24. So we're going to try g at 2, and then g at negative 2, and then continue on. And again, we don't usually write all of this out.
It's just something you do in your calculator?
You just kind of do it on your calculator. So like if I was doing it in my head, I would go 2 times 8 plus 9 times 4 minus 22 minus 60. Negative 30 didn't work. So no good. And I think g at negative 2 doesn't work either. I'm going to jump to 3 because I think it's 3. 2 times 27 plus 9 times 9 minus 33 minus 60. Nope. Negative 3 maybe? Negative 3. Therefore, x plus 3 is a factor. So I come off to the side, x plus 3, 2, 9, negative 11, negative 60. Imagine doing long division every time you had to do this. Okay, watch, therefore, now I don't care about g at x anymore. I was just using that because it's useful, again, to be able to write this out and write that out and everything, right? But really what we care about is f at x. So therefore, f at x equals the first factor that we found, which was x minus 2, and the second factor that we found, which was x plus 3, and then the quotient, which is 2x squared plus 3x minus 20. Should we do it again?
Yeah.
I think we should just factor this the grade 10 way, don't you think?
Oh.
We got a quadratic now. You don't have to use factor theorem and synthetic division anymore.
So in grade 10, we could have just used...
You could have learned factor theorem back in grade 10 and done it that way, I suppose, yeah? Yeah. Is that what you're going to ask?
Yeah.
Yep. Sure, it would work. But the hard part is, hold on. So let's factor this. This is something we will talk about probably next unit, but so it's not something we need to worry about yet. So this has to be 4 and 5, right? So 2 times 4 is 8 minus 5 gives me the 3x. Finding this is a little bit trickier with factor theorem because it's not just 5. So you would be able to find the x plus 4 factor. You would have been able to find that with negative 4, and you could have done it. But if you have these kinds of factors, they're harder to find. You can do it, and we'll talk about it later, but does that make sense?
Maybe. I don't know.
Yeah, don't worry about it. So we try 1, negative 1, 2, negative 2. You might be able to rule them out. Like, again, when I look up here and I think about adding up those coefficients, there's no way it's going to be 0. If it's even close, I would try it. Unless you're really good at estimating, really good at that mental math. And now it's factored, fully factored. So now we're done. Yes? I don't think so. Because this is going to be 8x minus 5x gives you positive 3x. Ah. Okay. Questions, questions, questions. All right, let's keep going. Let's try some more. That's how you do it. That's it, folks. That's the show, but we're going to try to squeeze 3 more examples in, and I'm just going to show you little tricks and tips that will help speed it up, and then you have to practice because you have to get good at this because we're going to do this for the rest of this unit, which isn't that long, by the way, because we have a test on Friday. We'll talk about that after. The rest of this unit, and almost all of the next unit and a lot of unit 5 as well will be kind of using this stuff. So you got to be good at this kind of factoring, okay? So, like I said, I'm going to show some tips that you don't necessarily need, but it will help speed things up and cut your workload a little bit. How's that sound? And some of them will be optional. Like I'm going to show you one thing, but it's kind of tricky and some people don't really get it, and that's fine. Don't bother. But some of you will get it and some of you will like it. Make sense? Sort of? Not yet, but okay. Everybody got that written down? I'm going to scroll back up to the first question, and I'm just going to point something out. So just put your pencil down and watch for a moment. What can I say about these 4 numbers and their relationship to the original question? And specifically that.
When they multiply all together,
They're going to multiply. 2 times 3 times 5 times 4 is going to give me the 120, right? No, positive. Better be positive. They have to equal to that. If I expanded this, right, I got 2 negatives, so that's going to be positive. And if I expanded, I'd be multiplying those together to get back the original question. So when I'm testing values to try to find a factor, like how can I narrow down that list? What do I have to test, or what could I or should I test for this question? Everything you try, this will cut your, if you miss this, you're just doing extra work for no reason that you don't have to. But won't they have to be factors of 27? Like there's no point in trying 2 and negative 2, right? Because they would be in the answer like this, but that's not going to multiply to that. So I'll try 1 and negative 1, and then I can jump to 3 and negative 3, and then I could jump to 9, I guess. So imagine on a test, if I gave you one where you had to go to 9, and you tried every number all the way up. 1, 2, 3, 4, 5, 6, 7, 8. And then you're like, Mr. Belair told us that he wouldn't give us questions like that. But you didn't have to try all those. Right? So it'll cut your workload a lot if you pay attention to that and you're thinking. Okay, so why don't you go ahead and try to find the factor. Maybe somebody already did. I don't know. Like I can tell right away 1's not going to work. because those are 3 big negative numbers and those are 2 small positive numbers. That's not 0. Negative 1 works? Anybody else? Yeah? Because negative 1 would be 2 minus 5 minus 15 plus 45 minus 27. 0. Therefore, x plus 1 is a factor. Yeah.
How much work do we have to show? Like,
You have to show this. You don't have to show anything else.
what if there's a ghost term?
Then you use a ghost term. For sure. Is there, did I miss it? No, there's not one in this one. Yeah. 45 minus negative 18 had better give me negative 27, and it does. And then times 1 is negative 27. And remember, that's not a coincidence. That has to happen to a remainder. Well, the whole point is it's got a remainder of 0. If you get to the end of doing the synthetic division or whatever you're doing, and it's not a remainder of 0, something's gone astray.
Isn't it? Wait.
What's wrong?
Isn't it negative? Negative 2?
I don't think so. 2 times 1 is positive 2, isn't it?
Wait, it's x plus 1?
Yeah. F at negative 1 is 0, so x plus 1 is a factor.
Why could positive 5?
Why is what a positive 5?
Isn't negative 1 to the 3 still?
But that's for evaluating this. I just use these coefficients in there. I don't. Okay. I think we're good. Are we good? Other people got that? We're good? Okay. So you could try negative 1 again. Does it work? No? 3? G at 3? Okay, I'm going to show you another little trick to speed things up. This is the one that I was talking about before. I was a little cryptic, I know, but some people will get this and some people won't. If you don't get it, don't force it. You need to be able to do some good mental math and get it for this to work. But it can save you synthetic division. But synthetic division is fast anyway. So like you're not saving yourself a lot of time. But when you get down to the cubic, there's a little trick that can save you a bit of time. But it's not saving you time if you get the answer wrong. So don't force it, okay? But you can try this if you like. Instead of doing synthetic division, but put your pencil down and watch. So x plus 1 and then x minus 3. And then what am I going to get here? Not specifically, but what kind of a polynomial is this? Quadratic? Degree 2? 3 terms, right? Maybe it's got a ghost term or something, but yes? Does that sound right? Okay, so what do I know about the first term? It's going to be x squared, and very specifically, what's it going to be? 2x squared. Doesn't it have to? If you missed that, because this times this is going to have to give me that, right? Okay. What's the last term going to be? How'd you get that? Negative 27. I've got negative 27 here. Positive 9, right? But not, yeah, very good. Do you see how that works? Plus 9 for the same reason, because this times this has to give me that. Yes? So I can find 2/3 of the last one very easily. The next part is the part that's a bit tricky, but just watch. Negative 3 times 2x squared is going to give me negative 6x squared, but I want 3x squared. So what do I need? So hold on. This gives me negative 6x squared. This times this has to give me something so that I get positive 3x squared. So what does it have to be? Nope. Bang. So this has to be 9x squared. And so I have to put something in there. So when it gets multiplied with x, see, it's like a lot of thinking. Like, this is what I mean. You got to get it. And some of you are like, I'm not following. And that's fine. You don't need to be able to do this. But it's a nice little trick if you get it. So it's going to be plus 9x. So that I get x times 9x is 9x squared. Negative 3 times 2x is 6x squared, negative 6x squared. And they have to add to 3x squared. You don't have to do that. You can just do synthetic division. But if you think you like that, and I'm sure some of you at least will get it, you can do that when you get down to the quadratic. Oh, and watch. I can check it because negative 3 times 9x is negative 27x, and x times 9 is positive 9x. So negative 27x plus 9x is negative 18. Like, I can do it with both. Right? I did it a lot faster that time, I know, but you can check it with the x squared and the x. Okay. If you think you like that and you want to see it again, maybe a bit more slowly or talk about it, come see me and we'll talk about it. Otherwise, use synthetic division, it's fine. And then we got one step left here, right? Because it's got to be 3 and 3, doesn't it? Yep. Any questions? All right. Now we just keep practicing more and more and more. First step, find a factor. Do the division. Then in your quotient of that division, look for another factor, divide again until you have it fully factored. Looking at this question, what are the possibilities? What numbers could I try and should I try when looking for the factors? Seema? Yeah, so 1, -1, 2, -2, 3, -3. No 4, no 5. If you didn't find one by then, I guess 6. Right? 6 could work as well. Okay, give it a try.
And what times or what line size equals that?
It's that first step of finding a factor can be frustrating. Imagine 1 works and somehow you miss it, and then 2 doesn't work and 3 doesn't work, and you've just spent like 5 minutes trying to find a factor and you can't find one. So I don't know what to tell you except to be careful and like do it slowly, use your calculator, you know, unless you're really good and really confident at mental math, but it's tricky, and unfortunately there is no other way. There's not like a secret way of finding factors. Sometimes you get a little bit better at telling, but there's no other secret. So I did get -1 works. I think people have got that and they're moved on from that, and then I found 2. And you might have missed -1, but 2 would have worked. Like if 2 works down here, it would have worked up here too, right? And that's it. There would only be those 2, because when I look here, I see that the other 2 would have been harder to find. So -1 and +2 would be the only things that would have really worked for that one.
Could you also do -1?
Does -1 work in that? It's worth trying, but I've already factored it out of x or of f. So it won't for sure work again. Right? Now, if you used 2 up here, then -1 is the one you would find for g. Is that what you did?
No.
Oh.
No, I did -1 at the top.
Yeah. So you could do them out of order. Those are still going to be, whether you do them in the order, like, remember what I said about prime factorization of the number 24? 2 times 2 times 2 times 3 is going to be the same as 3 times 2 times 2 times 2, or 2 times 2 times 3 times 2, right? Like you're going to get different order, but you're going to get the same things. Yeah. Ready to try one more?
No, it does not. Definitely wrong. But why did you go to 2? Okay, so you just have to remember, like, I could imagine someone, if it went to 2, they might not go back and try -1 again, you know what I mean? Because you've already got it on past tense. So as long as you know that you have to try it, then go back and try it. Doesn't matter the order, you just gotta make sure you find the factors. Yes. That's right. Exactly.
I got a case on that.
All right. Are we good? Everybody got this? There's one more to try.
What if the constant is a prime number?
Then you would only be able to use 1 and that number. But you could still have +1, -1, positive of that number, negative of that number. Like you could still have lots of, at least 4 options right there. This one looks to me like positives probably aren't going to work very well, because all of these big coefficient numbers are going to be really big, and I'm not going to be able to cancel. So like to me right away, this is the kind of thing where like as you practice and it'll save you some time if you look for those things. I don't think +1 is going to work. I don't think -1 is going to work. I don't think +2 is going to work. And I might start with -2. But in your head, again, like you might, and I think it works, right? Did anybody try -2? Like you might, you want to make sure you remember that you skipped some and you never tried them. Because if you start looking for another one and you're not finding it, maybe you made a mistake and you go back, right? Don't like overestimate, I guess.
say that it can work for both middle terms?
And this would
Okay, it's negative. So it's just negative 9x squared minus 4. Is that all? Okay.
I know some of you aren't done yet, but I'm going to put my solution up there. You can check yours when you're done. Any questions about any of this?